They always say that in space, no one can hear you scream. It's a line that conjures images of silent, sterile emptiness. And it's mostly true. Sound, as we know it, needs a medium to travel: air, water, solid ground. The near-perfect vacuum between the stars isn't a great concert hall. But the universe isn't a perfect vacuum. And more importantly, it wasn't always this way. Imagine a sound not from a dying star or a colliding black hole, but from the universe itself. A sound that existed before a single star had ignited, before the first galaxy had formed. A sound so powerful and so fundamental that it filled the entire cosmos, vibrating through the very fabric of spacetime. This wasn't just any sound. It was the universe's first song. A song that, for a very specific reason, was suddenly and permanently silenced, becoming a forbidden frequency we can no longer hear, but whose ghost we can still see everywhere we look. To understand this sound, we have to travel back in time, way back, to about 380,000 years after the Big Bang. Forget stars and planets. At this point, the universe was an impossibly hot, dense, and opaque fog. It wasn't empty space. It was a cosmic soup of fundamental particles, protons, electrons, and an overwhelming flood of light, or photons. This glowing plasma was so dense that light couldn't travel freely. A photon would move a tiny distance before slamming into an electron, getting scattered in a random direction. The entire universe was like the inside of a star, a single, unified, glowing entity. And this primordial plasma was the perfect medium for sound. Sound, after all, is just a pressure wave, a ripple of compressions and rarefactions moving through a substance. And the early universe was ringing like a bell. But what was striking this bell? The answer lies in a cosmic tug-of-war between two of the universe's most powerful forces. On one side, you had gravity. The quiet, relentless pull of gravity was trying to clump matter together. It would find infinitesimally small, denser-than-average patches in the plasma and start pulling more and more material in. But on the other side, you had the immense pressure of light itself. As gravity compressed a region of plasma, the photons trapped within it would get squeezed together, heating up and pushing back outwards with incredible force. Gravity would pull in, radiation pressure would push out. Pull, push, in, out. This cosmic battle created massive, rippling vibrations that propagated through the plasma at over half the speed of light. These were the sound waves. The entire universe was humming with a deep, resonant frequency, a single, universe-spanning chord. Scientists, by studying the faint afterglow of the Big Bang, have actually been able to figure out what this primordial sound was like. By analyzing the scale of these ancient ripples, they can translate them into an audible frequency. The result is haunting. The fundamental note of the early universe was an incredibly deep B-flat, about 50 octaves below the middle C on a piano. It was a bass note so low and so profound that it's completely beyond the realm of human hearing. But it was there. For thousands of years, this deep hum was the only song in existence, a monotonous yet powerful drone that shaped the cosmos. The peaks of these sound waves were areas of high pressure and high density. The troughs were areas of low pressure. This simple pattern was the blueprint for everything that was to come. Then, suddenly, the music stopped. The universe kept expanding, and as it expanded, it cooled. It reached a critical milestone, a temperature of about 3,000 Kelvin. At this point, it was finally cool enough for the protons and electrons flying around in the plasma to slow down and combine, forming the first stable, neutral atoms of hydrogen. This event is called recombination, and it changed everything. In an instant, the opaque cosmic fog cleared. The photons, which had been trapped in a constant game of pinball with the electrons, were suddenly set free. The universe became transparent for the first time. And with the plasma gone, the medium that the sound waves had been using to travel simply vanished. The cosmic hum had nowhere to go. The waves were frozen in place, like ripples on a pond that had instantly turned to ice. The universe fell silent, but the sound didn't disappear without a trace. It left an echo, a fossil. The pattern of the frozen sound waves, the specific distance between their high-pressure peaks, was imprinted on both the light and the matter of the universe. The light, now free to travel, carried this pattern with it across the cosmos for 13.8 billion years. Today, we see it as tiny temperature variations in the cosmic microwave background, a snapshot of the moment the sound was silenced. And the matter? The high-density peaks of those frozen sound waves had slightly more gravity. They became the seeds, the gravitational anchors around which matter began to clump. Over billions of years, these seeds grew into the vast clusters and superclusters of galaxies we see today. The empty troughs between the waves became the great cosmic voids. The entire large-scale structure of the universe, the cosmic web of galaxies that spans billions of light years, is a physical monument to this ancient, forbidden sound. We can't hear it anymore, but we live inside its architecture. Every galaxy you see is just a frozen note from a song the universe is no longer allowed to sing.